Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Networks can be grouped into categories based on their size, scope, purpose, and the way their components connect. The CompTIA Tech Plus certification includes questions on physical network types such as local area networks, wide area networks, and smaller categories like personal or metropolitan networks. It also includes logical organization models such as client-server and peer-to-peer. Understanding these classifications is essential for selecting the right architecture, diagnosing connectivity issues, planning for scalability, and applying security controls. In this episode, we will cover how networks are defined, how they are structured, and how devices exchange information in each model. A local area network is a network that connects computers and devices within a limited physical area, such as an office building, school campus, or residential home. Local area networks are designed to deliver high-speed and low-latency communication, often reaching speeds in the hundreds of megabits per second or higher. Connections may be made over wired Ethernet using twisted pair cables or over wireless fidelity using access points. Local area networks are typically owned and managed by a single organization, which maintains control over routing, switching, and device configuration. These networks support activities such as internal file sharing, print services, and the use of local application servers. The defining characteristics of a local area network include its use of private Internet Protocol address ranges and the presence of internal services, such as the domain name system and dynamic host configuration protocol. Devices on a local area network may include desktop and laptop computers, smartphones, printers, network-attached storage devices, and wireless access points. Centralized management allows consistent performance and easier troubleshooting. The network's physical topology can take the form of a star, where all devices connect to a single switch, a mesh, where multiple paths connect devices for redundancy, or a hybrid design that combines elements of both. A wide area network covers a much larger geographic area and is used to connect multiple local area networks together. Wide area networks may span cities, countries, or even global regions. They are often built using leased telecommunication lines, fiber optic circuits, or satellite communication links to carry traffic over long distances. The public internet is the most well-known example of a wide area network, but many organizations operate private wide area networks to connect branch offices, data centers, or cloud services. A wide area network may be owned by a business, leased from a carrier, or provisioned through a managed service provider. Comparing a local area network to a wide area network highlights important differences in design and operation. A local area network is private, local in scope, and offers predictable high-speed performance. A wide area network may be public or private, covers much greater distances, and offers speeds that can vary depending on the technology used. Local area networks are usually managed directly by the organization that owns them, whereas wide area networks often rely on contracts with internet service providers or telecom carriers. Local area networks excel at supporting internal operations, while wide area networks are essential for connecting external resources, remote locations, or distributed systems. Troubleshooting each type requires different tools, knowledge, and coordination. A personal area network is the smallest type of network, designed to connect devices that belong to a single user within a very short range, often less than 10 meters. Examples include connecting a smartphone to a wireless headset using Bluetooth, pairing a smartwatch to a mobile device, or linking a laptop to a wireless printer for quick printing. Technologies used in personal area networks include Bluetooth, infrared communication, and near-field communication, often abbreviated as NFC. These networks are usually temporary or session-based, require little infrastructure, and prioritize convenience over high speed or long distance. A metropolitan area network covers a geographic scope larger than a local area network, but smaller than a wide area network, typically spanning a city or a large campus. Metropolitan area networks may connect multiple buildings for a university, link government offices throughout a city, or provide services for a large corporate campus. They are often managed by telecommunications companies, or through partnerships between public and private organizations. While not as common on the exam as local or wide area networks, understanding metropolitan area networks is important for grasping how infrastructure scales from small local designs to regional and national connectivity. Network topology refers to both the physical and logical arrangement of devices and connections in a network. A star topology uses a central hub or switch to connect all devices, making it easy to isolate failures but dependent on the central device. A bus topology, now mostly legacy, uses a single backbone cable shared by all devices, which can be inexpensive but vulnerable to single points of failure. A mesh topology connects every device to multiple others, creating redundant paths that improve fault tolerance and load balancing. Hybrid topologies combine elements of these designs to meet performance, cost, and resilience goals. The chosen topology affects network speed, cost of deployment, and the ability to recover from failures. In the client-server model, client devices such as desktops, laptops, and smartphones request resources or services from centralized servers. These servers may host data files, business applications, printers, or authentication systems. This model simplifies management by centralizing control, allowing administrators to enforce policies, deploy updates, and monitor performance from one location. Client-server networks scale well as organizations grow, but they require robust infrastructure and thoughtful planning to ensure uptime, security, and performance. The peer-to-peer model allows each device in the network to act as both a client and a server. In this setup, devices share resources directly without going through a centralized server. Peer-to-peer networks are easy to set up, cost very little to operate, and are common in small home networks, temporary workgroups, or ad hoc collaborations. However, they lack centralized control, can be difficult to secure, and do not scale well for large numbers of users. They are best suited for small environments where ease of setup and flexibility are more important than strict management or auditing. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Hybrid network models combine elements of the client-server and peer-to-peer approaches to meet varying needs within the same organization. For example, a small business might store critical data on a dedicated file server while still allowing direct peer-to-peer printing between a few desktop computers. This blending allows cost savings on certain functions while maintaining control over essential services. Over time, many organizations that start with a hybrid model migrate entirely to a client-server configuration as their needs grow and the benefits of centralized management outweigh the lower costs of peer sharing. Common services in a client-server environment include file servers that store and distribute documents, print servers that manage print queues and permissions, authentication servers such as those provided by Active Directory to control logins and enforce policies, and email servers that route messages between internal and external addresses. Each service is hosted on robust hardware with dedicated resources and is protected by access controls to maintain integrity and availability. The use of these centralized services simplifies administration and improves reliability compared to uncoordinated peer-to-peer setups. The client-server model offers notable advantages such as centralized management, streamlined backup and restore processes, and stronger security through uniform access control. It also enables administrators to apply consistent updates and patches across the network. However, these benefits come at the cost of higher initial investment in hardware and software, as well as the need for skilled information technology staff to maintain the systems. Organizations using this model must actively manage uptime, resource allocation, and security monitoring to ensure the network meets performance and compliance requirements. In contrast, the peer-to-peer model's strengths are its ease of setup, very low cost, and flexibility for quick or temporary use. It allows devices to share files, printers, or media directly without complex configuration. The limitations are significant, including minimal scalability, weak or inconsistent security, and lack of centralized oversight. This model is most appropriate for home networks, small laboratory setups, or short-term collaboration projects where the administrative overhead of a client-server system is not justified. In regulated or security-sensitive environments, peer-to-peer networks are generally unsuitable due to audit and compliance challenges. Workgroup and domain models describe how user accounts and permissions are handled across networked systems. A workgroup is decentralized, using a peer-to-peer structure where each device maintains its own user accounts and permissions. Domains, in contrast, are centralized under the management of a domain controller, which stores all user accounts and enforces network-wide policies such as password complexity and account lockout rules. Domains allow for easier administration in medium to large organizations, while workgroups may still be found in small office or home office environments where centralized control is not needed. Routers and switches play key roles in both physical and logical network models. A router connects one local area network to another network or to a wide area network, managing Internet protocol traffic between them and often providing network address translation. A switch connects multiple devices within a local area network and forwards traffic based on media access control addresses. Managed switches can segment traffic using virtual local area networks, apply quality of service rules, and provide monitoring features. The effectiveness of any network model depends on the correct configuration and deployment of these devices. Addressing also varies between network models. Local area networks generally use private Internet protocol address ranges assigned by dynamic host configuration protocol services, while wide area network connections may require public addresses and network address translation to connect internal networks to the Internet. Host names and the domain name system help users locate services and resources across different types of networks. Careful address planning and documentation improves routing efficiency, security, and troubleshooting in both small and large environments. Common real-world network scenarios illustrate these models in action. A remote office may connect to a corporate headquarters through a virtual private network running over a wide area network link. A home office may use a wireless router to manage a small local area network that connects laptops, printers, and smartphones. A school might deploy a client-server model to centralize authentication, manage printing, and host shared file storage. In other cases, an ad hoc group of laptops at a conference might share files over a temporary wireless hotspot using peer-to-peer connections. The CompT Tech Plus exam may present scenario-based questions that require matching a described use case to the correct network type or model. For example, a question might describe a small business with centralized authentication and shared printers, which aligns with the client-server model, or a home network sharing files directly, which aligns with the peer-to-peer model. You may also be asked to identify whether a connection is a local area network or a wide area network based on the devices and distances described, or to interpret topology diagrams to locate routers, switches, and access points. Key glossary terms to reinforce include local area network, wide area network, metropolitan area network, personal area network, topology, star, mesh, client, server, peer, domain, and workgroup. It is helpful to use flashcards to match these terms to real-world examples or technical characteristics. Network maps and diagrams can also be effective tools for reinforcing how each type is organized and how devices connect. Understanding the terminology will improve your speed and accuracy on exam questions that require quick identification. In practice, networking knowledge is required in many information technology roles. Support teams manage local area network cabling, wireless configurations, and switch port assignments. Systems administrators configure routers, manage domain accounts, and secure client-server environments. Remote workers depend on secure connectivity through virtual private networks and often operate in hybrid environments that blend local and cloud resources. Mastery of network types and models ensures that you can plan, maintain, and troubleshoot environments of any size. In the next episode, we will examine wireless capabilities, including the wireless fidelity standards, frequency bands, and factors that can cause interference. You will learn how the different 802.11 technologies compare and how environmental and configuration choices impact performance in small and large wireless networks. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.